Well, hi, everybody. This is John Sarver, and this is another My Solar Story. But tonight we have a treat. We're going to have a My Geothermal story. And this is sponsored by GLREA and the Michigan Solar Users Network. And tonight we have Alan Waller, who's on the GLREA board and also a manager for WaterFurnace, is going to talk to us about geothermal and also the installation that was at his home. Until we get to the question session, please mute yourself so that we don't have any interference. And with that, Alan, take it away.
Hi, everybody can hear me? And thank you for inviting me and being able to share my story of geothermal heat pumps. And geothermal heat pumps by far is the most energy efficient way of heating and cooling your home or business. And we're using the earth and transferring the heat from the earth into the home to heat your home, and then vice versa. In the summertime, we reverse the flow of refrigerant, and we take the heat from the home and put it back into the earth, where it just heat moves to cold and it transfers thermal, with the thermal conductivity. So I got a little video here I want to share that I put together. It's about 3 minutes long, and I have 5 vertical bores, 200 feet, and I'll go ahead and let the video here start, and hopefully the share screen works, and I'll expand it, and everybody can see that now. Can they see that? Okay, and I'm going to play, and this is my old air conditioner. And then here's the drill rig out there, and they did 5 vertical bores, 200 foot deep. And it's basically a drill rig here that water and mud type rig. I'm very fortunate. I live across the street from a lake, and they hit water at 65 feet. So water is a good conductivity of heating and cooling and transferring the heat. And then this is how they put the plastic tube down. This is 200 foot coil, so there's 400 foot of tubing per circuit, and there's 5 circuits that they drilled into the ground. And then the loop contractor, he comes out and he trenches about 4 to 5 foot down, and he connects the 5 different loops that were going vertical. And then the vertical loops were 3/4 inch plastic tubing. He uses now 1.25 inch plastic tubing to connect the circuits and bring the median into the house, the source load, which is water and methanol, about 10% methanol. So there's about 100 gallons of fluid out here in my loop in the ground with about 10% methanol, which is about 10 gallons. And here they're heat fusing. They're fusing the plastic 400 to 500 degree iron, and then they put the plastic fittings together and they fuse that together, which is stronger than the pipe itself. And then they come back and they rebury it. So now there you see my power plant that's buried in the ground, which absorbs all the sunshine out front there, and is a heat sink for us every day. And then he uses his Bobcat, flatten it all out, and he power raked it, which is really nice. I had grass growing there in a week. Come in and power raked it and smoothed it all out real nice. You couldn't even tell it was done. Here's my old Lennox Pulse furnace, 90% gas furnace. Hauling that up and out of there. And then here's the new WaterFurnace 7 series variable speed compressor unit. And it's similar in size of your regular furnace, but it provides both heating and cooling. It has a variable speed compressor, uses a variable speed blower motor, and a variable speed water pump or flow center. It's a water to air product, so we're going to use force air to distribute through the home, and they connect it right up to my ductwork with my return air and supply air. Here's the flow center here on the side wall. You have your furnace and your humidifier, and then here's my hot water heater. That's a water to water unit, connected to an 80-gallon hot water storage tank. So that is my system installation. And I want to stop that and then stop the share. So I need to get off that other page. Any questions on what that was there and on how that was installed?
Well, I have all sorts of questions, but is this the proper time?
Well, I can go, let me
Okay.
show you something else then. Hang on. With my system, I gotta open this page, I think, first. I'm gonna share my screen. And I'm gonna go to this is the Symphony Insight program that WaterFurnace had put out. Can everybody see that? Yep, good, okay. Currently, there's over 7,000 geothermal systems in the United States hooked up to our Symphony Wi-Fi program, monitoring all our WaterFurnace units out there every 10 seconds. And down below shows the annual average cost of all these systems out there. So for complete United States, average cost about $444 for heating, $218 for cooling, with an annual cost of $669. That's pretty much an average of all those units at about 13 cents a kilowatt. So I could come here and I could click on Michigan. And these are all the systems I have here installed in Michigan. And currently I have 409. And the average heating cost, $668, 130 cooling. Your total cost for a geothermal system average in the state of Michigan about $800 a year. But now I can take that and filter it and say, oh, we're going to go with the 5 series dual capacity unit, and you need a 4-ton unit in your home. And then that's going to show me all the units here in Michigan. Oh. And with, well, sorry. So with that, a 4-ton system, average cost in Michigan is around $885 a year or $74 a month. Well, then I can zero in and like, here's a high consumption one right here in the middle of the state. So they averaged of 7693 kilowatt hours for the year at a $962 per year or $80 a month. And then I can go to one that doesn't use as much energy. There's 404,459 kilowatt hours or about $560 a month. And this is true actual data. And I could zero in on my system, and I'll show you my system hooked up to Symphony. But this has been great for case studies, proof to the utilities of actual savings and energy consumption. And it's just been a great tool for our dealers to use. And then I could get now, I could go to our most advanced system. That's our 7 series with the variable speed. And then they go up to a 5-ton unit. And then I could show you then the capacities on that and what that is here for Michigan. And again, there's all the dots here that have been installed with the 7 series. I have a lot more in the Ann Arbor suburbs there. And again, this is a high usage one here, about $1,100 a year. It could be a larger home, basically. That's why they got the higher cost there. So that's our Symphony program. And I'm going to drop out of that. And then I want to go to my Symphony. Hang on a second. And I got to open that up. And my system's on the Wi-Fi Symphony program also. And I'm going to log in. I'm going to share my screen now. Where'd it go? Can you see my screen?
Not yet. We can't see the
Hang
screen
on.
yet.
I'm sorry. I don't know what's. I hope I don't lose you here. I don't know what I've done here that I can't get to my screen. Here we go. No. I could just see John. I can't see anything else here. Oh, hang on. There we go. Here we go. Now I can share screen. And I want to go to, let me go to this. I'm going to go to this one here. Here we go. Does everybody see my Symphony now?
Yep, we can see it.
Okay, this is my home system actual operating right now. I have 3 zones. They're all set at 70 degrees. It shows I'm in compressor speed 1, and with our variable speed compressor, we actually have 12 speeds with a super boost for cooling. So if you had a big gathering or a party and it was a hot, humid day, you can go to the Go Boost Super Boost and pull in extra dehumidification. But currently my loop temperature is 63 and my return air is 70 degrees and my supply air is 54. And with the compressor speed at 1, we're running at a very low wattages and the fan motor and the consumption of the pump. So everything is really at the lowest speed and lowest energy consumption to maintain my 70 degrees right now. The warmest I've seen my loop in the summertime is about 65 degrees. And then in the wintertime, with the polar vortex we had a couple years back, I got down to 35-degree loop temp. And then within a week later, when the the troubleshooting chart here, and this is what the contractors can see from their phone or their computer, and then also even troubleshoot from the office. It takes a second to pull up, but it's coming. It'll be here. Of course, it's slow when I need it to be fast, but we could also configure our unit from remotely. Homeowners can see and control their temperatures from their phone, or let's say their second home up north, and monitor and see what's going on. But I don't know why I'm not getting connected now to my troubleshooting form. Here we go. I'll try it again. Let me go back to dashboard. Here's my dashboard. So I could actually then go to thermostat and then actually play and control. The thermostat actually looks like the exact one at my home. So I could actually then change it to the 71 and I'd actually turn everything off. I could go to different modes, and here's your heat off and cool, and the fan auto on type thing. I could also look at my different zones and see which ones are open or closed. And then also I could dial in the size of my zone. So like zone 1 is 70% of my system and needs 70% of the energy that's to heat and cool. And then the other zone is 25% of the area. And then the other zone I got set up for about 45, which currently I only have 1 zone open right now. And the other 2 zones have met temperature. So it's another way of, again, utilizing and showing it. Then also I have energy consumption here. And it shows, and again, it's not pulling up. I guess I don't know what's going on with the computer. but here it's, well, it's not showing the graphs here, but it pulled up a couple of them here by scanning them. So the average of that month, not showing anything. But I don't know why it's not pulling up my data right now. So there's something going on. But that's been a good system for us. And again, it's been proven to show what's going on. Now, can they still see my screen, the reliable renewable, or no?
No, we don't see the screen anymore.
All right, let me try this now. I'm going to go to this quick little PowerPoint. It should be able to see, it says the reliable renewable.
Yeah, I see that.
Okay, and then I'm going to move this out of my way. I'll just go this way. So that was a new trademark slogan that we promote for geothermal, and that's the reliable renewable. And we're talking beneficial electrification, where we're using a complete home and using nothing but electrical. And even in subdivisions, geothermal communities, so forth, we want to just have a complete electrical, it's already there, you might as well use it. Why spend more money to bring in gas lines and underlying gas type things? So, plus electric is getting less carbon. There's more renewable energy, solar and wind producing our electric, which makes it cleaner, less carbon. So that's something good. This is just a neat little picture of you got the chimney over here on the house putting out your carbon monoxide, and the guy's got a Volt in the driveway. Well, what efficiency is that? Annual household consumption. And this shows here in the Midwest that we're using about 94,000 million BTUs average in the home, which actually creates, it's about 75% of the energy use that we use on a daily basis. And over here it shows Midwest household energy by end usage. Thermal demand is about 75% of our energy consumption. So if we could take these million BTUs, or 27.6 million watts an hour, and then 25% of the average home uses electric. So they're using it for lights, washer and dryer, your refrigerator, your TV. So 25% of the home already is electrical. So the other part is 75% is thermal. And there's the amount of BTUs, or the amount of million watts an hour. And then we can convert that and transfer that into the electrical use of thermal, the savings in renewable energy. And again, the geothermal heat pump delivers 100% thermal output, which 75% less input. Well, and then the gas efficiency furnace, you always got something going up the chimney. You're not getting 100%, but with geothermal, we're getting 300 to 600% efficiency, depending on the unit, depending on the type of loop that's going in the ground, or if we're using an open loop or a pond loop. But we're providing renewable energy. We improve the utility load factors. We do have extreme efficiencies, high climate resilience, the unit mounted indoors. We got a long life cycle. It's weather independent and high level consumer benefits. But with weather independence, like air conditioning in the hot summer months, we got an outdoor air conditioner trying to get rid of hot air, and it's least efficient when we need it to be the most efficient. Where geothermal now, we're transferring that heat into the earth or a loop that's only at 60 degrees. So the heat just disappears automatically. So here's, again, our Symphony Insight. And then this, back then, they only had 4,500 systems installed. And the annual savings there, 514 for heating and so forth. So they're just using that as, now Indiana, where our plant is located, those are pretty much the same standard, average cost of what you're seeing in Michigan. 5-ton or 4-ton 5 series unit, it costs around $700 a year. So with a quick review, especially with utilities, geothermal helps provide seasonal load variation, beneficial electrification, long-term fuel certainty, peak load reduction, and it gives them recurring revenue. And also, the they can get into owning their own loops. So they do provide the highest net present value for them, and the utilities easements are simple. Assets are good for over 100 years. They could do on-bill financing and doing maybe energy tariffs and so forth to help recuperate their loop costs. But there are some companies, Southern Indiana, utilities down in Oklahoma, Minnesota, have done some of these loop lease programs and have been very successful with them. And it helps, I think, the energy companies. The biggest one, I think, is the peak demand, lowers their peak demand. So that was just a little bit about the electrical and so forth there. So now I'll take it some questions.
Hey, thank you, Alan. And time for some questions. Just unmute yourself if you have any.
Well, Alan mentioned a pond and heat source, and also horizontal tubing and vertical tubing. So what are the pros and cons of each of those if you have them available?
Well, there's a little bit of difference now. With the vertical loop, you're going to have a higher expense with the equipment to be brought in and do the drilling. So when I did my vertical loop, they charged me $850 a foot. I had 5 vertical bores, 200 foot, that was 1,000 foot. It was an extra $8,500, where the contractor would come in with his excavator and dig the horizontal trench. So on my vertical loop, I only had 400 foot of tubing per circuit because our ground is more constant temperature the deeper you go. On a horizontal loop, they're going to be 4 to 5 foot down, and they're going to use probably 600 to 800 foot of tubing per circuit to offset the difference, because our loops will get colder on the horizontal than they would in the vertical. And then they also could do directional bore. And a lot of the guys with directional bore will go down about 12 foot down and come back up and then pull the tubing back through. But it's also important that they try to, what I wanted to say is they use Mennonite earths to make sure we're getting good ground contact with that, not just relying on the earth closing back in on it. So with a pond loop, same thing. You got to have a good amount of a pond area. It has to be 12, 15 foot deep always without drying out or affecting the level. And they usually put those in 300 foot coils with little spacers in between. And they'll usually do one of those coils per circuit with one extra. So if you had a 4-ton unit, a lot of times they'll put 5 circuits out in the pond. And they weigh that down with cinder blocks and some other things and tie them down to the base of the pond, which normally your pond water at the base of the pond at floor level there is about 45 degrees. And it's a constant 45 degrees. So that is, so you're, and then we also do open loop. So open loop is we're pumping, dumping. We're using about 2 gallons a minute per ton. So a 4-ton unit was going to use 8 gallons a minute to circulate through our unit and then go out to a drain field or a pond or a marsh. And that system is the most efficient because our water temperature always stays 50 to 52 degrees. It's always the same temperature, and we're always extracting the same amount of heat. Where like a horizontal loop, our loop fluctuates down to about 32 degrees. And that's why we use the methanol to keep it from freezing. And then again, we're extracting the heat from the earth. And again, depending on the ground, good, soil, wet, heavy clay soil is great heat transfer compared to sand, or like over in the thumb area along Lake Huron, there's a lot of sandy area. Those guys are putting 800 foot of tubing in the ground to offset that because sand is not a good heat transmitter. So yeah, there is some advantages and disadvantages, but we size them correctly to maintain the load in the home, that we're pulling that amount of heat from the ground, matching the heat or load to the home. And we have a program called GeoLink, and the contractors can go in and put that data in this program and figure out, one, if their loop is sized correctly, to what is the energy consumption and how much it's going to cost, and then compare that to a gas appliance. And I did my house here, and currently at the cost they are, I'm only saving about $300-400 a year over natural gas at the current cost. 5 years ago, I was saving about $800, but my electric rates have gone from 10.5 cents to 13 cents to 16 cents in the last 5 years. And I'm on AEP, or Indiana Michigan Power. So that's.
Alan, we got some questions in the chat box. I don't know if I brought them up. I don't know if you can see them. The first one has to do with the heating costs shown in Symphony include auxiliary electrical heating costs. That kind of assumes that there is an auxiliary electrical heating system, because I know that's true with some, air-to-air heat pumps. But do you have auxiliary electrical heating systems? And if so, were those costs shown in your Symphony chart?
Yes, and those costs would be included. In fact, when I could pull up this GeoLink program, let me see if I could get that up. I thought I had it up earlier, and pull up my system where you could pull up some bin data, and it shows you, let me find it real quick. I'll see if I could share my screen then. Let me see if I could pull up my report. Oh, that's what I want to do. Here it is here. GeoLink report.
Well, maybe we should just go on to the next question. The next question is, can this be used on a system that uses all hot water for heating?
Yes, yes. In fact, we have water-to-water units that could our standard units go up to about 125-degree water temp. They work great. You saw the unit that I showed at my domestic hot water. That's just a little 2-ton unit. And we have an 18,000 BTU unit, a smaller one. But they go all the way up to our residential, up to 5-6 ton capacity. And then we have our larger units that go up to 15 and 20 ton capacities. And it's water to water, just like a boiler. We also have a unit that's called the OptiHeat. And that produces hot water up to 145-degree outlet temperature. So,
okay, thank you. Thank you,
I want to
Alan.
go back to
Other
the
questions? Barbara, do you have a question? You unmuted yourself.
Yeah, we have geothermal. We have open loop. When we put it in 13, the person that installed it recommended Climate Master. He knew how to install, but he actually didn't know how to fix. So our current HVAC person highly recommends WaterFurnace, and we will go with that when this one dies. And I'm just wondering, we have open loop, we have 80 acres. At the time, it was a lot more expensive to do the closed loop. Do you think we're losing a lot of money with the open loop as opposed to the closed loop?
Not necessarily. Open loops are a little more maintenance because you have a mechanical valve opening and closing. And also, depending on your water quality, it might cause a little bit of iron buildup, or
it does have iron, yeah.
Does it? So you have to have your system cleaned or flushed. That coaxial coil or heat exchanger might have to be cleaned periodically, yearly or every other year, where a closed loop system not necessarily has to. Now listen to this. You're using a well pump, 230-volt well pump, maybe a 1/2 horsepower, 3/4 horse pump to pump and use that water to change that. With a closed loop, we're using a small fractional horsepower. Like
yeah, I do know that. We have an efficient pump, so they tell me, and the pump got hit by lightning last year. So now we have a brand new pump.
Well, I hope you went with the constant velocity pump. It is,
yeah. It is.
That's much better and more energy. I went to the same thing. My well pump here went out. I'm in I've been living here 28 years now, and it was about the 18-year mark that the well pump went out, and the guy talked me into going a new velocity pump. And I noticed that it does give you better water pressure when more people are using it in the house,
Right.
But also, though, the difference between open loop and closed loop, again, might be a little bit more maintenance on the open loop compared to the closed loop. And, but your efficiencies, again, are there, but, I hope that, again, you don't have to replace a well pump in the future.
Yeah, and we've been very happy with ours, and I'm able to offset the use of coal, but because our co-op or electric co-op allows me to pay $12 a month for the offset the coal use. So it's been good.
Wow. Well, whose electric co-op are you on?
Alger Delta. I'm on the Upper Peninsula.
Yeah, yeah. And sorry to say, your electric rates, what are they charging you up there right now?
25.
That's what I heard, about 25 cents a kilowatt hour. So
Yeah.
it makes us tough to sell geothermal up there when it uses electricity, you know?
I know. But we love ours. We've been very happy. And I just wanted to be green with the best I could do to be green, you know?
No, that is. And again, I appreciate it. And again, it's, how long ago has your system been in now?
It was put in 13.
23, so only 6-7 years now.
Well, like I say, when this furnace goes, we'll definitely be going with WaterFurnace.
Well, hopefully it lasts you like it's supposed to, about 20 years, you know?
Think so? I don't know. We'll see.
It should.
I hope so. Cross my fingers.
Hey, Alan, could you talk a little about a battery backup in case you lose power? Are folks putting in battery systems in order to maintain their geothermal systems? I assume the battery systems are, probably going to be powered by solar systems, but I wonder if that's happening now too. There's a lot of interest now in battery backup systems.
Well, and we're also come a long way now with our locked rotor amps. We, on our standard equipment, our 2-stage unit we can order what they call the IntelliStart. So on a 4-ton system, on a standard unit, has a locked rotor amp, so like 104 amps on startup. So the initial startup and the rush of electricity to get that compressor turning is a locked rotor amp draw of 104 amps, which is pretty high. With the IntelliStart added on, it's a couple $100 option to the contractor. I think it's about a $400 list to the homeowner. And that drops the locked rotor amps about 60 to 70% to around 35 amps. So that really is helpful with solar battery. But then our 7 series, our variable speed compressor, the unit I've had here in my house now over 5 years, that startup on that is only around 10 amps. That's almost like your little vacuum cleaner there in your house. So with the lower amp draws on startup, and again, with my system now running on first speed, has very low amp draw, very low energy consumption, which I think is ideal for then the solar with battery backup. But I'm not sure what, like my average monthly usage here is around, I think it's around 1600 kWh. So, and that's my average. But I did notice though that in the long term, I think that would help dramatically of getting you to net zero, having that battery backup and not selling your extra electric back. And I think in the summer months, you probably still have a full load on your battery and be able to sell some back to the power companies. So,
well, here's a question for you, Alan. He asks about a water versus water-air comparison in costs, and it's a roughly 3,000 square foot home with in-floor heating, looking to go vertical and wondering about how to get an upfront estimate cost. He's in the UP and planning to be off-grid for electricity as well.
The guy in the UP there, we have a couple dealers. If you go to waterfurnace.com and then go to find a dealer, you hit residential, and then up in the top right corner it says find a dealer. I know there's Hoholic there in Escanaba, and they're very affluent with our products. But yeah, water to water, the added cost is the in-floor tubing over the air-to-air ductwork. You have more circulating valves, and depend on a 3,000 square foot home, you can zone that out, probably about 4 to 5 different heating zones. And then, but if you want air conditioning, you still got to run ductwork. You still got to run some ductwork. I know up in the UP, your air conditioning season is not very long, if at all. You got plenty of trees for shade, and it seems that you do have the cooler. You might have some hot days, but you got the cooler nights, where down here in southern, I live in near Kalamazoo area, we get those hot muggy nights, you know, so I don't think they get those as much up in the UP. But there's the big difference. Water to water is going to be about the same cost as a water to air unit. The added cost is in the floor tubing, the labor, and the material, the zone valves, and so forth, compared to just running duct work and connecting it. But then if you want air conditioning, the water to water units do reverse and do produce chilled water. And by the way, now we have systems up to 300 tons, and they're heating and cooling like Florida University, Ball State University, and some of these other larger projects. But we've really concentrated on getting more of those larger projects. And in Florida, they did a pond loop and a ground loop. Reason being, it's primarily a cooling atmosphere. They're always cooling compared to heating, and the loops always will get 95 degrees. They'll get up there because they're discharging so much heat in the loop. Now they could switch to the pond loop and give that other ground loop a chance to rest and cool off. So they have like a bi-loop there. They can go both, either pond loop or ground loop, to offset their heat when the loops get too warm. And I found that out in Oklahoma too. They get some hot loops down there where, you know, one gentleman said he had to put the sprinkler on and let that sprinkler soak his yard down because the loop is pretty sandy ground and it just was too warm to just discharge all the heat from the house.
Hey, Alan, what do these systems cost? What would be the range of costs that you could expect? Obviously, you have some systems that are bigger than others, but what's kind of your typical cost, or what's a range of costs that a homeowner could expect?
My system, in most systems, I think that 3 to 4 ton range are going to be in that $20,000 to $24,000, depending on the area that you live and where you're at. I mean, I cover the whole state of Michigan, and I know, like, my one dealer here in Berrien Springs, he installs over 100 units a year, and he just, they got it down so quick, and their crew is just so efficient at putting them in. You know, they're doing I was surprised. A guy told me last week we changed out 5 units. I'm like, wow, that's fantastic. But they do so many of them. Their costs are a lot less than somebody else, maybe in the Ann Arbor or Detroit area. And it's part of the labor, I think, and then also the cost of excavating and the cost of putting the loops in. So it varies around, but I'm going to say your average system is going to be around 20 grand. And then with current 26% tax credit, you're going to get $5,200 back, which you'll be down to around, $14,800. And at that price, with the savings overall in over gas, LP, or oil, your savings on gas or the LP and oil will be within 3 years. And with the gas, I think of 5 to 7 years, with natural gas being as cheap as it is. But that's going to change. I don't think that's going to stay as cheap as it is. And
folks, if you want to ask questions, you can just unmute and ask Alan directly. You don't have to go to the chat box. We have a small enough group that we can do that. I think, Lee, you had a question.
Well, I was at the solar show in Munich one year, and I talked to a guy from London, and I asked him, if you live in a residential area of London, which is a cloudy city and very small lots, how would you build a zero energy home there? And he related a water furnace type scenario, except that they excavated an extra 10 or 12 feet under the house and generated an insulated mass of earth underneath the house where the water loop ran. And when you look at the thermal cycling seasonally, that's pretty cool, because that box of dirt underneath the house becomes quite warm when you get into October, September and October. And when you get to December, the sun is the weakest, but the box underneath your house is the hottest. And then when you get to April, the box under your house may be pretty cold by now, but the sun is pretty bright in April. And it was pretty interesting to see how well matched the sun and the temperature of the storage container and the house, how that worked together. And that's one of the reasons I asked Alan, how far south does he have to go before he can balance the amount of solar radiation with the need for air conditioning as compared to the amount of solar radiation and the requirement for heating. As you go farther north, that gets more and more out of sync.
Yeah, I agree.
But as you go farther south, if you go to the Mason-Dixie line, what happens?
Yeah. Oh yeah. Now I know exactly what you're talking about. Back in my college days, I went to Macomb Community College, and they had one of the first pretty much energy efficient building. They had solar, wind, but we also had rock storage, and it was the same thing, that we were storing the heat from the day into the rock bin, and then in the evening we'd circulate air through the rock bin, and that would pick up that extra, radiant heat that we absorbed from the sun. And like you say,
yeah, but that was daily. That was daily storage. I'm talking about seasonal storage.
You're talking longer term, and I agree with you. Where when you go south, and when we discussed in school with air-to-air heat pumps, we always felt that south of Indianapolis and that Indianapolis range was the best area. From there south would be an air-to-air heat pump year-round, because up here we can't pull out much heat out of the air after 32 degrees, even though air-to-air heat pump says, hey, we could get down to 0 degree ambient now, but they're not very efficient. They're really working very hard to try to pull any of that heat out of the ground or out of the air. And they're just not very efficient at that point. But I understand the thermal mass.
At zero, what is the coefficient of performance?
Oh, it depends. We're still pulling that COPs of at 3.5 to 4.2. So we're still very efficient, even at, like you say, I'm sizing our systems here in Michigan at 0 degree ambient and 90 degree ambient in the summer. So 0 degree ambient, actually with the ASHRAE numbers and our GeoLink, our certain areas of the state would be about, here in Detroit area, I think it's about 1 or 2 degrees. And when I get up to Traverse City, it's about 0. And then when you get into the UP, it's about -2 or 3. And then your ground temperature shows a great deal of difference too, from Detroit area of about 55 degree ground temperature, 52, up to Traverse City would be about 40, 45 in that range. And about a little bit different up in the UP, which again, we have more hard rock up there, and it makes it harder to put loops in the ground and a little bit more expensive for an air type driller than it is a mud water driller like you saw at my place. So I find that we're having a hard time getting good loops in the ground up in the UP or in the northern Michigan area because of the high amount of rock that's there. But it's hard for me to detail of what that balance point is, but I know when you get south of Indianapolis, you've got a good strong balance point of stronger for the cooling than it is the heating.
And is that based on air-to-air exchangers?
Yes, basically.
Yeah. Yeah.
And we're getting more hot days in Michigan and across the country, of course. So we're getting these more extreme temperatures now.
But also now, some of the guys we talk when we have different classes and stuff, and we got people coming up from Indiana to our class, or I got guys in Michigan, they might be putting a little less loop in the ground too, where they might just do a 400-foot horizontal per circuit, where I'm at 600 to 800 foot horizontal. They just a little bit, because they're not getting it as cold, or they don't have as long of cold cycles as what we have. But yes, that's similar of what you're speaking of, the heat sinking under the home versus that. Now, Viridian Country Farms now in Ann Arbor is supposed to be starting their project next year, and that's going to be a GeoLoop community, and it's going to be set up by a company called Orica, and they're going to come in and they're going to put all the loops in for everybody on this, and then cover all the costs and all the infrastructure of all the looping, and then charge the homeowner like a $20 or $30 a month fee for their utility or their ground source loops. And it sounds like their homes are going to be 1,500 to 1,800 square foot, and they're usually going to put 2 vertical loops right under the garage area and then go right through the sidewall into the basement for the unit itself. So they're planning on maybe 2 or 3 possible vertical loops that will go right in underneath the garage or along the foundation of the basement in the garage area, and then pull the loops in through the sidewall, which is a pretty neat concept. And then they'll cover all the cost and infrastructure and then bill them back as a geo utility, which is kind of neat.
You know, there were a couple houses, low energy houses built in Lexington, Kentucky, where they ran the loop around the outside of the footer.
Okay.
And that kept the coldest part of the house, the place you always get mold and condensation on the bottom corner of your house. That kept it a little warmer in the summer. And then they ran it in the sewer trench out to the street and back.
Yeah.
And so they were able to get back any warm water heat that went out to the sewer.
Yeah.
And they didn't have any extraneous piping. They just ran around the footer of the house and out to the street and back, and that was it. All the excavation was done as part of the house construction rather than special activity.
Yeah, special looping. Now, up here, we don't like to see the loop within 10 foot of the foundation, because I've seen and have heard where the loop got so cold that it built up frost around the outside of the piping, which then actually cracked the foundation wall and moved it about 1 inch.
Oh,
And,
wow.
yeah, because they kind of ran out of room in the backyard, was what the homeowner explained. And then as they brought the last circuit down through, they came down along the house and then brought it into the house. And when he had called me, they had a ball of ice that was coming in through the wall. And he says, my wall has cracked. And they just figured it was part of that. And we've always been a strong advocate of keeping them away from septic systems, your foundation. We don't like to do them under driveways either, because we like to have moisture and transfer of moisture and rain. But they've been doing them under parking lots and commercial applications. And you're usually going in commercial about 300 to 400 foot deep, and most of their loops. So down here at Midwest Electric Co-op in Cassopolis, brand new facility they opened up last year. They have a whole bunch of, maybe, I don't know, 30, 40 units in there. And they have 140 loops that are like 350 foot deep each circuit. And they come into the main pumping room and mechanical room with like 12-inch main coming in with 2 different pumps so they can leak and lag. And then they reduce that all the way down throughout the building to all the different units. So another one was the LaFontaine car dealership there over near, what is that out there by Brighton area, just east of Brighton there. But they have about 30 or 40 units in their facility also throughout their system. And they have, again, 100 and maybe some 20, 30 loop drilled out and back under their parking lot. And the same thing with a 12-inch main coming into the building and circulating that throughout the facility. So, which is really neat on commercial. Your outer area of the building in the wintertime is a heat, we need heat. And in the center of the building or inner areas of the building, even where they have computers and they have server rooms and stuff like that, they need cooling. So it really works great when you're taking heat from the loop and putting heat back in the loop, either through the computer rooms and the server rooms and so forth. So that really balances out a loop and really makes it energy efficient.
Any other final questions before we kind of break for the night? Any final questions for Alan?
I was wondering about connecting to a boiler run hot water system. I've got mostly baseboards in my house, but I don't know if there's time for him to answer that.
Yes, we have a unit now that puts out like 145 degree water temp, where a boiler back in the day, they would size that boiler at 180 degree temperature at 0 degree outdoor ambient. So, and then most of the homes are usually oversized with the radiators and the baseboards. But then if we put in a geothermal system and we're only running maybe 140 degree water throughout the system, we might have to add some baseboard heating in some strategic places to offset that temperature difference or to maintain the BTU load of the home. But depending on how old the home is, you were most likely way grossly oversized with your boiler. And there's a ton of energy savings, even if you went to a modulating boiler. And I'm not sure what fuel you're using, if it's natural gas, propane,
It's natural
or
gas.
is it natural gas? So,
Yeah.
you know, again, the newer boilers, and yes, we can work in conjunction with a boiler or even a wood. You see the wood boilers outside too, where the guys, sorry to say, I always tell them we hug trees and not burn them, but there's a lot of guys that like burning wood and doing the hot water heat to their house or air coil on top of their furnace. Well, we can offset that with a water to water unit and maintain the heat same way without all the extra labor involved. I tell them,
Alan,
Yeah, I think,
I tell them
I'm
to keep a
sorry.
logbook when they're burning wood.
Alan, there's a question about why you plastic tubing, because it doesn't conduct heat very well.
Well, it lasts the longest. We actually have systems. I know WaterFurnace has been in business about 35 years now, and we've actually got loops and guarantee those plastic SDR 11 tubing for 55 years. And they're actually saying they're going to last longer than that. They're going to probably last 100 years, which could probably last for 3 to 4 geothermal systems. So as you think about it, you know, if you had to change your equipment out in 20 years and you still got your loop in the ground, you gained a lot just by having that loop still in the ground, and not have to pay, you know, another system. Where outdoor air condenser only lasts maybe 10 to 12 years because of the weather and the way they get beat up and weatherized, and our units are indoor, should last longer. But yeah, with the hot water, again, with boiler, we can do it with a boiler and hot water, and not have to, you know, if you're not interested in the cooling, you don't have to do reversible.
I am. I had a space pack in the attic, but I'm on solar only, so I can't use the air conditioning anymore.
No? Okay.
Well, I
I've
think
been using attic fans at night.
go ahead, Buddha.
Thank you. My question is on the service of the systems. I know that looping system, that I commonly read that's a century or better. What is it that you're looking at that's got a service life of 20 years? Is that simply having a pump reserviced, or what all does that entail as far
That
as?
would say the unit. Actually, AHRI say our unit, that big box, looks like a furnace down in your basement or your crawl space, or it could be in your attic. That should last actually about 24 years.
Okay.
The life expectancy of our equipment should be approximately 24 years. Where a furnace that creates combustion, those things usually only last, I don't know, 15 to 18 years, you know, and an outdoor air conditioning unit is 10 to 12. So we kind of feel like, yeah, we get twice the amount of use, lifespan on our equipment than the other guys.
What's the cost of that equipment as, say, a percentage of total installation?
I'm going to say a 4-ton unit lists for about 10. It's about half. It's about half the cost of the system.
Okay.
Yeah,
Thank
that'd be a good guess.
I'm just looking for a ballpark. Thank you.
Yeah.
I have a quick question for John or about natural gas price riders. Does our electrical company have a fuel adjustment clause in their contract for selling electricity? And if the price of natural gas would double, what would happen to our electric prices?
Yeah, electric rates are based on a pass-through of fuel costs, and so there is no money, there's no earnings on a fuel cost. It's basically just a pass-through. The Public Service Commission kind of regulates that. Of course, there's always the issue: are the utilities getting the best, lowest cost fuels, whether it's gas or coal? So that is a issue in rate cases before the Public Service Commission. But yeah, if natural gas prices go up or coal or whatever, those costs are just passed through in the electric rates. That's correct.
And remember that DTE owns gas pipelines at another part of their company. So they have a self-interest to support their other side of the company as well. So just like John says, they're not looking to get the lowest price for gas because that means the other part of the company doesn't make as much money in selling.
Well, actually, though, in the last week, I was contacted from a gentleman there in the gas side of the business from DTE. What we can do to help them get some natural gas power plant, multi-million-dollar facility going to be they just broke ground on it. So like you say, if gas prices go up, that means our electric costs are going to go up.
Yeah, this
And
is
there are actually people around asking questions about a 700 megawatt system in the Toledo area.
Yeah.
The gas is going to be our problem if price goes up.
Yeah, there's an article I posted on the GLREA Facebook where Alan and Larry Kaufman are quoted in talking about geothermal systems. So if you want to learn more, there's a nice article that we posted on the GLREA Facebook page.
And that was from DTE Energy Smarts magazine. So again, here's a power company that is helping promote geothermal renewable energy because one, they know it reduces their peak demand during the summer months. That's one of the biggest benefits I think they see in it. And it provides them a year-round good income, especially in the wintertime when they got plenty of capacity around. So.
Yeah, well, we're at 8 o'clock, so I think it's time to break. Alan, thank you very much. This has been very interesting. We appreciate you taking time to talk to us about geothermal.
Well,
and thank you for everybody
me.
for attending tonight. And, you know, if you know people who have missed this presentation but are interested, all the recordings are posted on YouTube under the Great Lakes Renewable Energy Association channel. So you can kind of if you find somebody who's interested in any of the topics that we've covered, just direct them to our YouTube channel. And thanks again for attending. Thanks again, Alan, for that interesting presentation. And, you know, take care, everybody.
Thank you again. Have a great night.
Thanks, Alan.
Yes, thank you guys. Thanks, everybody.